we are going to be talking about a subject that's near and dear to my heart. We're talking about correcting common mistakes in async and await in .NET. Now, this is filled with stories and examples of mistakes that I've made. When I was first learning async and await, it was so easy. You just add that async keyword, you await a task, done. But I kept finding my code was acting weird. It was doing things that I didn't expect. And I'm a mobile app developer. My background's with Xamarin. I used to work at Xamarin. That's actually how I landed at Microsoft. But I remember I would have QA or tests. They would come to me and they would show me the app and say, "Hey, it's in this weird state. It's broken." And then I'm like, that's not good. So I go back and look at my code, and I look at the code, and I'm like, well, there's no way the app can do that because I didn't write that. And so I ended up diving kind of deep into the .NET async and await world and wanted to share with you all the cool things I learned. Now, the big caveat, async and await, multi-threading, all of this is really, really hard. I kind of equate it to learning physics. You know, when we first learn physics, they say, oh, Newton's laws. Everything follows Newton's first, second, third laws, and then you go to physics 2, and they're like, well, actually, Einstein figured out everything was relative, and then you learn all about relativity, and then maybe you go to university, you take another physics class, and they go, well, actually, it's all quantum theory, and there's a bunch of strings and quips and quirks. So that's kind of how I think about async and await. We're gonna be staying up here at that physics 1 level. We're gonna get down into it, but there is always more to learn. So that being said, you'll see there's a link here at the bottom of the slides. This link will be available on most of the slides today, but make sure at some point, take out your phone, grab a picture of that, because this is a web page I put together just for you, just for today. This is where you can go to find the slides from today. This is where you'll be able to find all the open source code from the sample apps we're looking at today. And if you're feeling crazy, if you want to keep learning about async and await, I have a bunch of links in there to blog posts and Microsoft documentation, all crazy stuff where you can keep diving deeper down into the world of async and await. So that being said, let's get started. Multi-threading. So it's important to start with multi-threading because, well, this is why we have async and await. Async and await wouldn't exist without multi-threading, and multi-threading is kind of one of the best and worst things that's ever happened to us as developers. Multi-threading allows us to execute a lot of tasks parallel, so we don't have to hit an API once, wait for that to finish, then hit the API again. We can all do it at the same time, but with that great power comes great responsibility, and so with multi-threading, we get a whole new challenge for us as developers. So one of the nice things, though, with multi-threading is that my computer's on the fritz, so let's fix that real quick. Actually, if you could do me a favor, I need to fix that, but if you see that happen, just kind of jiggle the mouse and it'll bring it back. Don't actually click it, because that'll go to the next slide, but thank you so much if you could help out. Usually I don't have this big of a stage to walk around. This is amazing. So, thread pool. Yeah, one of the nice things with .NET is .NET basically handles threads for us. This is something that I am so thankful for in .NET. This is why I love writing code in C#, because if you want to spin up a new thread, you don't have to worry about anything. The thread pool is going to handle that for us in .NET. Now, if you've ever written code in other languages that has to handle threading, well, every time you want to spin up a new thread, well, you have to keep track of what that thread's name. You have to release it, return it back to the thread pool. You have to know what thread called that thread, and it's just crazy. But in .NET, we have the thread pool, so we don't really have to worry about that. Now, with the thread pool, there is a maximum number of background threads. It is whatever the size of your machine is. So it all depends on the size of the virtual memory available on your box. So what's kind of cool is that same code running on, say, my mobile device will have a different number of threads in that same code running on a back-end server with maybe 64 gigs of RAM. And what's also nice with the thread pool is even if we use up all those threads, so the thread pool, that'll give us, depending on the size of your machine, hundreds of threads, tens of hundreds of threads. If all of those are used up, it'll just still queue up those tasks. So if our code says, hey, I need another thread, the thread pool goes, sorry, we're all full, but you can hang out right here, because when that next thread finishes, the thread pool just passes your task along to the next available thread. So really cool feature in .NET. And here's kind of how all that looks with some code. As I get closer to my computer, there we go. So we have a method here called read data from URL. And this is a pretty simple method. Now, yes, we're using web client in here. You should be using HTTP client in your code, but just for the sake of keeping it simple, we've stuck with web client. Now, all this code is doing is we are newing up a web client. We are calling download data task async, which we're awaiting. That returns a byte array, which we've called result. We're taking the byte array, turning it into a string, and then running this method called load data. So what's really happening here with multi-threading is this method gets kicked off by the first thread. Now, in this case, we'll call it thread 1. Now, thread 1 doesn't necessarily always kick this off, but for the sake of example, we'll go with thread 1. Thread 1 is also commonly known as the main thread. It's also commonly known as the UI thread. This is the thread that in your app, if you are making a web app, if you're making a desktop app, if you're making a mobile app, anything with a UI, thread 1 is what paints that UI to the screen. So thread 1 is a really important thread, and we don't really want to use it if we don't have to, because if thread 1 runs download data task async, well, maybe that takes 5 seconds, and that means our app is essentially frozen for 5 seconds. So what do? Well, we say await, and a different thread, a background thread. In this case, we'll call it thread 2, runs download data task async. Now, it's not always going to be thread 2. This might be thread 17. It might be thread 73. But we're calling it thread 2 for the safe example here. And so thread 2 is actually running the download data task async method. And thread 1 is free to go back and interact with the user. So now while we're doing this download, thread 1 is available to respond. Maybe the user's scrolling, maybe the user's tapping buttons, those button clicks, the scrolling, that's all handled by thread 1. So we're good here. Thread 1's free. Our app's not going to be frozen. And so when thread 2 finishes, there we go, it calls back to thread 1. Thread 1 actually comes back into this method to finish executing all the code. Now, computers are ones and zeros. The threads aren't actually talking and shouting to each other. What's actually going on here is we're using something called the synchronization context. So thread 2, when it's all done, it goes to the synchronization context and says, I'm all done. The synchronization context says, OK, great. What thread called you? And it goes, thread 1. So then the synchronization context, that's when it grabs thread 1, and that's how thread 1 jumps back in here to finish up the code. So that's what's happening, but why is it happening? How is it happening? And to understand that, we need to dive a little deeper. We need to look into what's called the intermediate language. You might have also heard this called IL, or some folks call it MSIL for Microsoft Intermediate Language. This is what the compiler turns your code into. So when you click compile and you get that DLL file, that's actually in IL. It's optimized code. It's all boiled down into one binary. But let's take a look at that same method in IL. I got to remember to stay close for the clicker. There we go. So here's our same method. And here is what it looks like after it's been compiled. Now, the first thing I want to point out is the compiler has turned our method into a class. Every async method, when you click compile, becomes a private sealed class inheriting from iAsync state machine. Now, we didn't write a class, but the compiler turns it into that, and because of this, it adds a little bit of overhead to our app. So every async method ends up a class, and that class adds about 100 bytes of size to our DLL or to our app size. So, 100 bytes, it's 2018. We've got servers with terabytes of hard drives. What's 100 bytes? Maybe it matters, maybe it doesn't. But nowadays you can even do .NET on IoT devices, and yeah, that 100 bytes could add up. Back to the other side. There we go. So those local variables we created in our method, those have become private fields. And the compiler does rename them, but if you squint a little bit, you can see that it's essentially the same name. We have our private string data, we have private byte array result, we've got web client WC, and then the public string URL, that's the string parameter that we passed into the method. And the reason why the compiler adds in those funny angle brackets and numbers is just the compiler doesn't know what we've called these variables, and it does that just to make sure that the variable name's still unique. And then lastly, move next. If you've ever had to debug or look at a stack trace of an async method, I guarantee you've seen move next. And this is what kind of started me on my journey down into this world of async and await and how does it work, because I kept seeing move next in my stack traces, and I was so confused. I was like, I never wrote a method called move next. What is that? Well, move next, this is where all of your code executes. And in the simplest sense, move next is just a giant switch statement. And we get one case by default, which is case 0. And then every time we call the await keyword, move next adds another case. So in our example, we just use the await keyword once. So we have 2 cases in our switch. And if we take a look, case 0, this is the first code that gets executed. And so this is where, in our example, thread 1 newed up a web client. And then thread 1 kicks off download data task async, and then it returns. And so this is how thread 1 is actually free. It's actually able to go back and interact with the user because it's actually returned out of move next. Now, before it returns, it sets that value of PC to 1. And it does that because when the background thread, when that thread 2 is done running download to task async, thread 1 comes back in, and well, now PC is equal to 1, it goes to case 1. And this is how thread 1 picks back up and continues running that method where we get the results, which is the byte array. We turn that byte array into a string, and we bring those slides back up. There we go. And then we kick off that load data method. Now, pretty cool. This was all kind of created because, well, the .NET framework existed before async and await did. And so kudos to the really smart developers on the .NET framework team for figuring out how to give us just a async await keyword, and then they kind of handle all the rest in this giant state machine. But all of this is wrapped up inside of a try-catch block. Now, I didn't write a try-catch block in my code, but what the compiler does when it generates move next, all of that gets wrapped up in a try-catch. So if any part of my code throws an exception, it's caught right here. Now, let's imagine maybe there's no internet connection. Maybe that download data task async failed. Well, that exception's caught here. And no worries, because we, in our code, had awaited it. And as long as we use that await keyword, that exception will get rethrown. But this is where I see a lot of developers mess up, because how many times have we kicked off a task and not awaited it, right? We say task.run, go, I don't care when you finish. But when we do that, if that code throws an exception, that exception's caught here. And because we didn't await the task, that exception's gone forever. We'll never know about it. And this is why my app got into these weird states where, I'm looking at the code and I'm like, there's no way the app should even be running in this state, but it was because the exception got essentially swallowed up inside of the task. So quick review. Async keyword adds about 100 bytes. So is 100 bytes a lot? Not really, but good to know. So every async method becomes a class, and that extra overhead adds about 100 bytes to our app size. Await every task, whether it's an async task method, whether it's task.run. If you are kicking off a task, make sure we await it, because if you don't, that exception will be swallowed up, it'll be gone forever. So let's fix some code. I brought with me a sample app today, and this is a mobile app that I wrote using Xamarin, and it's pretty simple. It's just something to help me read the news. I like reading the news in the morning, and my favorite news site is called Hacker News. If you've never heard of it, they just post a bunch of cool tech articles. So if you want to stay up to date with the latest, greatest things in the tech world, check out Hacker News. But yeah, all this app does is there we go. I can do a pull to refresh. I can get the latest stories, and then I can tap on any of these stories and read more about it, just like you'd expect. So let's check out the code that's actually running here. Now, I will say, don't worry about memorizing anything we're talking about. All of this code is available for you. It's all open source. It's at that link that we shared earlier. I'll give you one more chance later to snap a photo of the link if you haven't already. But inside here, we have a view model called Good Async and Await Practices, and we have one called Bad. So we're going to be working, and we're going to be fixing bad. But the reason you don't have to memorize anything is because it's all already done in good. So feel free to check out the code later after we've already cleaned it up during the talk today. All right, let's jump into the methods first. So this method down here, execute refresh command. This block of code is what runs every time the user does a pull to refresh. And this is just, it goes out to the Hacker News API. It gets the top 20 stories and then displays them to the screen. Now, right here, I'm calling .wait. Never use .wait. Don't use it. It's a code smell. Rip it out of your apps, and I'll tell you why. Well, the obvious answer here is that we are inside of an async task method, so we should just be awaiting this. We shouldn't be using .wait. This is what we should be doing, but what .wait does, it actually holds on to the calling thread. So what happens, let's say thread 1 kicks off this method, and then setIsRefreshing is going to be run on thread 2. Now, because we called .wait and we did not use the await keyword, well, thread 1 is told to wait right here. Thread 1 is held hostage, even though a different thread may be running this method. So what have we just done? Well, if that is thread 1, we've just frozen our app. Now, let's say setIsRefreshing takes 2 seconds. Our app's going to be frozen for 2 seconds because thread 1's held hostage. And this is bad because we're now using 2 threads when we only need 1. We didn't release thread 1 to continue on interacting with the user. We've actually held it right here. So .wait makes you essentially use double the threads. And this is not so a common problem in APIs, backends, where we have a lot of people hitting our services can be something called thread exhaustion. And that happens when we use the .wait keyword because we're essentially using 2 threads every time we only need 1. So .wait's bad. Now, Now you might be thinking, well, Brandon, I have some code. This code has to run synchronously. What option do I have? I have to use .wait, right? No, there's a better way to do it. So if you have to do this synchronously and you cannot use the await keyword, I recognize that's kind of getting rare nowadays. Most of the code we write is async and await, but for that 1% chance that we have to do this synchronously, get await or get result. Get await or get result does the same thing as .wait. It's still going to hold the calling thread hostage. Thread 1's still going to be stuck here where the background thread executes this method. But the reason get await or get result is better is because when we use .wait, if an exception is thrown inside of our method, so let's say somewhere inside of set is refreshing, an exception's thrown. Well, .wait will rethrow that exception, but instead of rethrowing our exception, so maybe there was a web exception that was thrown, we don't get a web exception from .wait. We get what's called an aggregate exception. And aggregate exceptions are kind of weird. They're an exception made to hold multiple exceptions. And so if you're familiar with aggregate exceptions and you know how to dig into them to find your exception in your stack trace, great. But get await or get result will actually throw our code. That'll give me my stack trace and my exception, and then I don't have to dig through this weird system.aggregate exception. So super, super helpful. So that's why I say never use .wait. .wait's a total code smell. If you have to use it, replace it with get await or get result. If you don't have to run it synchronously, use the await keyword. Now, something that's also kind of cool is, let's see. So this method actually returns a bool. Let's see, bool is successful. And like we expect, I could await this and I could get that Boolean result back. But again, what if we have to do this synchronously? If we cannot use that await keyword, you're probably thinking to yourself, easy answer, .result. Never, 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 never use .result. Just like .wait, total code smell. When you get back to the office tomorrow, if you see .wait or .result anywhere, rip it out. Ideally, replace it with the await keyword. But again, what if we have to write synchronous code? Well, there's a better option than .result. And just like .wait, it's get await or get result. Get await or get result not only replaces .wait, but it also replaces .result. Now again, this is going to run synchronously. Get await or get result will hold that calling thread hostage. You're gonna use two threads, but if you have to use that .await keyword or that .result keyword, replace it with get await or get result. Just like with .wait, .result doesn't throw your stack trace, you get back that aggregate exception, whereas get await or get result, if the code does throw an exception, we get back our exception with our code and our stack trace. So all that being said, we are in an async task method here, so we're just going to use the await keyword. Now the next three factors down here, and this one's easy because, well, we just talked about it, we should use await instead of .wait. Done. Okay, the next method. This is called getTopStories. What this method does, move that out of the way. There we go. What this method does, it first hits the Hacker News API to get the IDs of the top story. Then once we have those, we iterate through the IDs where we actually get the stories, we add them to the list, and then we return them in descending order. Now, what's wrong with this method? I mean, aside from the fact that it's not executing in parallel, we could have written this better, but figured I'd keep it simple, at least for the sake of example here. Well, what's going on here, just like we talked about earlier, a thread will kick this off. So let's say thread 1 kicks off this method. executes this line of code. Then a background thread runs this. So let's say thread 17. And then when thread 17's done, it goes back to the synchronization context. Synchronization context says, great, you're all done. Which thread called you? Thread 17 goes, thread 1 called me. So then what happens? Well, thread 1 comes back in and continues executing this code. Now, this, again, isn't great for a couple of reasons. Like the example we're using again, we're talking thread 1, which is the main thread. We never want to overutilize the main thread, but even if it wasn't, maybe this is code running on a backend API where there is no UI. We don't have to worry about the main thread. Well, it will still return to the calling thread. And what if that thread's busy? What if that thread, because it went back to the thread pool, or in thread 1's case, thread 1 doesn't live in the thread pool. The main thread, the UI thread, is slightly different exception. But anyways, what if that calling thread's busy? Well, the synchronization context has to essentially add it to its queue. So we have to wait until the calling thread is available before it can come back in and execute this code. So the way we can make this better, we can add configure await false. So just a quick FYI, if you don't say .configure await, it's actually there. It just defaults to configure await true. And what configure await true means, it means return to that calling thread. So if thread 1 kicked off this code, and then thread 17 runs right here, configure await true says, well, go back to thread 1 for this code right here. Configure await false does the opposite. So with configure await false, when thread 17 is done running get top story IDs, it's still going to go back to the synchronization context. The synchronization context is still going to say, okay, great, you're all done. What thread called you? But with configure await false, thread 17 is going to say, doesn't matter. So that frees up the synchronization context to grab whatever thread's available. So we don't have to return to the calling thread. We just grab whatever thread is available. So configure await false, now we don't have to worry about, was that calling thread busy? It's just going to continue executing on whichever thread's available. So if we have, say, thread 1 enters the method here, and thread 17 runs this method here, because we have configure await false now, a different background thread, maybe thread 20, will now come in and run this code. And so our code's going to run a little bit faster. We don't have to wait for that calling thread to become available. And so done with that refactor. And down here, same story. We'll just say, lost my parenthesis. There we go. Configure await false. All right. Couple more refactors. This one right here, get top story IDs. Now, this method is what's hitting the Hacker News API. This is what's returning to me the list of the top story IDs. And take a look at what this method returns. This returns a task of type list of type string. And if we look at get data object from API, and let's zoom in on that IntelliSense there, get data object from API also returns a task of type list of type string. So what we can do here, we can actually get rid of this async keyword, get rid of the await keyword, and we can just return this task. So because it's still returning the same type, now we can get rid of that async keyword. That means we don't have that compiler overhead, so we've saved 100 bytes out of our app. And because we were awaiting get data object from API, that was actually switching threads. That was a context switch. So not only do we make our app just a little bit smaller, but it's going to run run a little bit faster now, because now we don't have to switch threads to call that get data object from API, and then also switch threads when we come back. So pretty cool refactor there, and I know it looks weird. This one took me a little while to get used to, but now I love it. I think of return await as a code smell too, and so that's why I went through my app and I ripped out return await everywhere. And well, here's another method. This is get story, and this is also calling the Hacker News API. This is what actually gets a story, but check it out. Same idea here. The only place in this async task method where we are using the await keyword is in the return statement. So should be an easy solution, right? We just learned this. You rip that out, you rip this out, and happy days. That'll still compile. This will work, but this is a trick question. Because, yeah, return await should be a code smell, but it's not a super stinky code smell because sometimes it's okay. And the reason we actually want to keep it here is if we return this task, that means we're done. This method's done executing. It has returned the task, meaning it's exited the method and it's exited this try catch block. So if I actually wanted to catch an exception from this get data object from API method, it'll never be caught here because we've already escaped the method. So this is actually one of the examples where we want to keep that async await keyword here, even though, like I said, return await, yeah, it's a code smell, but it's not as stinky as .wait or .result, because if an exception gets thrown, I do want to catch it and I do want to handle it here. Another good example of why you would want to keep return await is if this was inside of a using block, you know, those using statements that'll dispose of your object when it's done with it. That's another lesson learned. I ripped out return await, just return to the task, and it was inside of a using block. And well, what happens? We returned right away, the object got disposed, and now I got all these weird null reference exceptions. And so we're going to keep return await here, but I do want to show you something else that's kind of cool. Value task. Now, value task is very new, and actually it is coming in .NET Standard 2.1, but I'm able to use it here in my project because it is available via this Nougat package. So if you want to play around with value task, it's available in system.threading.task.exceptions. I've added a link to that to the website that I shared with you earlier. So again, don't worry about memorizing that. But what is value task? Well, if we think back to our .NET memory management deep dive, right? Well, there's two types in .NET. There's value types and reference types. And reference types, they go into memory into what's called the heap. And if you remember back to your data structures classes, well, heaps are great because if you want to find something in a heap, it returns almost immediately. That big O notation for heaps, to get data out of it, is basically 1. You get that object back right away. But the reason you get it back right away is because it's expensive to add things to a heap. You've got to do a bunch of indexing, find the right place to put it, slide it in. And so if we don't have to add an object to the heap, we could make our code a little bit more performant. And value task treats the task as a value type. And in C#, value types go on the stack. So a little bit quicker to allocate that memory, but we got to be careful with value task. Now, we won't dive super deep into value task. I do have a blog post that I linked to on that landing page. Definitely check that out because value task doesn't have exactly the same behavior as task, so you got to be a little bit careful, but here's my recommendation. If the hot path in your method doesn't use the await keyword, take advantage of value task. So for this example, if I know that 95, 99% of the time, Story ID is null or white space, meaning I'm just going to return a null. I never really hit that await statement. Well, I don't really need all the benefits of the task, so I can use value task. That way I don't have to allocate all that memory on the heap. Code runs a little bit faster, a little bit more performant. Again, check out the blog post that I've linked because there are some very strange differences that you could run into. Task should certainly be your default over value task, but yeah, if we know that the hot path in our code won't hit the await statement, maybe we run this method 99 times and only once do we need to await it. Well, why bother allocating all that memory for the task and putting it on the heap? Because, well, we don't really need it. So we can take advantage of value task. All right, jumping up to the top. I have my constructor up here, and inside of the constructor, I'm calling this async task method. If you remember, this was the method that we cleaned up first. This is the method that just goes out, hits the Hacker News API, pulls back the top 20 stories. So it's what executes whenever the user does a pull to refresh in my app. But I have it here in the constructor because I don't want the app to load without the data. So when the app launches, I don't want to have to force the user to do a pull to refresh. It's a much better experience if we do the first pull to refresh for the user, right? But we're calling a task, and we're not awaiting it. And so, okay, well, I mean, Instinct might tell you, like, yeah, let's slap on the async keyword. We'll put in await right here. But this won't work. This won't compile because this is a constructor. We cannot use async and await in a constructor, and for good reason. Constructors are just made to initialize an object, maybe assign a couple properties, but that's it. They're not supposed to do any long-running tasks. So, all right, so can't do that. Well, one thing we could do, I could make this method, let's call it just refresh, and inside of refresh, we'll say await, execute refresh command, and then up here, we can just call refresh. Now, I know what you're thinking. We just made an async void method. Like, what the hell is this guy thinking? We're always told never use async void. And that's mostly true, but the problem I have with never use async void is they never tell you why. You know, when I was learning async and await in C#, I was just told, don't do it. It's for event handlers, and that's why it exists. Well, but let's look at what's happening here. We're kicking off async void refresh, and inside of that method, we're still able to await this task. So if this task throws an exception, we have the await keyword there. That means the exception will get rethrown, unlike when we were calling a fire and forget task, where that exception just gets swallowed up forever. So we did make the code a little bit better by creating this async void method, but here's why async void methods are actually bad. Because let's say this method, let's say this is an async void method, but it exists in a different class. Maybe one of my fellow developers wrote this, and I'm working on my code. I'm typing in, and IntelliSense shows me that this method I want to use that my coworker wrote that I've never actually looked at returns void. And what do we assume when a method returns void? Well, we assume that the next line of code after refresh will not execute until refresh is done. But what actually is happening here is if we had some code down here, maybe we had some code that said, this is where we newed up our top story list, and then we add some stories to it. So say add, we'll say ... for now. So my assumption is that because that returns void, this code won't execute until this code's finished. And that's just wrong, because this is actually running this execute refresh command in the background. And so execute refresh command, that's also going to be newing up a list. That's also going to be adding stories to it. And we're going to get some weird behavior here because of this async void method. So that's one reason why async void is bad. Another reason, let's say we wrap this up in a try catch block. And that's because, well, if refresh throws an exception, we want to handle it. Well, you can almost never catch an exception from an async void method. And again, that's because this method kicks off, and down here, it's actually running on a different thread, but we cannot await it, so this line of code essentially runs immediately. And so by the time this method actually throws an exception, we're already done. We've exited this try catch block. And so there's no way that we can catch this exception. So really, async voids methods are bad because it's tough to catch exceptions, and just the assumption we have as .NET developers, if we ever see a method return void, we assume that it'll be finished executing everything before the code moves on to the next line. So, all right, so we're not going to use an async void method here. What are we going to do? Well, I still want execute refresh to command to kick off here in the constructor. Let's see, lost the bracket there. There we go. Well, what I did, I actually put together some code called Safe, Fire, and Forget. Now, this was something that I teamed up with another Microsoft MVP, John Thuray, and he wrote a great blog post about how to do a fire and forget task, but still safely. And so we worked together. We actually put this in a Nougat package just last week. So this is hot off the presses. I've included the link to that Nougat package here for you. And if we look into what Safe, Fire, and Forget does, well, check that out. It's actually using async void. So still a little weird because, right, we're not supposed to use async void, but here's actually where it's a good case to use it. So this is just an extension method on task. So for any task, you can say .safe, fire, and forget. That task will still be awaited. And if an exception happens, we can actually pass in an action to handle that exception. If you don't, we'll just rethrow it. But this is now a safe way that we can kick off a task. So feel free to check it out. It is available on Nougat. The link's available for you on the landing page that I shared with you a minute ago. So now we can call execute refresh command in our constructor. We say safe, fire, and forget, and we don't have to worry about any of those exceptions being swallowed up. All right, last to do. Now, like I mentioned, this is a Xamarin app. In the Xamarin world, we love MVVM. We love that model view model. And MVVM uses iCommand. If you've never used it, iCommand is just a way for the view to invoke something in the view model while still being decoupled from it. The view still doesn't know anything about my view model, but it can still kick off this command. And inside of here, we have another warning. If I zoom in, that says, this is an asynchronous anonymous method returning void. And that's kind of just because the way commands work. Command takes in an action, and if you make an anonymous method, it returns a void for an action. So this is actually like an async void method. And now what we also did, what John and I did, we also added to that Nougat package async command. And so now I can just pass in this async task method, and it'll run safely. We'll make sure that if any exceptions are thrown, they get rethrown. Or you can even pass in things to handle that. So like if an exception is thrown, you can say to maybe you just want to print it to the screen. So you can say console.beachball. All right, there we go. console.writeLine, and we could print that exception to the screen. So just another way that you can safely execute tasks inside of a command. Feel free to check it out. Now, we just went over a bunch of stuff. So just a quick review. Async and await best practices. Never use .wait, never use .result. Error code smell, get rid of them. If you can, use the await keyword. If you have to do it synchronously, get await or get result replaces both. So again, if you ever see this anywhere in your code, rip it out. Well, I'm sorry, if you ever see .wait or .result anywhere, rip it out. Use the await keyword if you can. If you have to run it synchronously, get await or get result. Get a little closer. There we go. Fire and forget tasks. Don't do it. If you can avoid it, don't do it. You want to await that task so that we can rethrow the exception. But if you have to, we've created this safe fire and forget. That's in Nougat in a package called Async and Await Best Practices. And the link down here at the bottom of the slide will take you to, we've posted the link to the Nougat package on the link down here in the bottom of the slide. Async commands, if you want to check it out, we've made async command for you. That's also in a Nougat package available for you here if you're doing any MVVM work dealing with tasks. Here we go, clicker, there we go. Avoid, return, await. Now it's not always bad because if you're in a try catch block or if you're in a using block, we still want that await keyword. If you rip it out of those scenarios, weird things are going to happen. But if you're not, and the only place in the method that you're calling the await keyword is in the return statement, rip it out. We'll save the overhead from creating that compiler-generated class, and we don't have to switch threads, so we save a little performance on the context switching. Utilize configure await false. So if you don't have to return to the calling thread, configure await false. My rule of thumb, if I'm in my service layer that I know will never touch the UI, I configure await false everywhere. I never have to return to the UI thread, so I don't ever really care what thread I go back to. And just like the service layer, if I'm in my view model layer, that view model is never going to draw anything on the screen. It should never be needing the UI thread. I configure await false everywhere. And value task. This is available in the Microsoft's official system.threading.task.extensions Nougat package. If you have code that 99% of the time, the hot path doesn't hit the await keyword, check out value task. But highly, highly recommend you read the blog post that just came out last week on it. It'll explain exactly what value task is and the little subtle differences between task and value task. All right, if you haven't had a chance yet, now's your chance to take out your phone, grab a picture of this link, put it in your browser, save it, share it with your friends, because this is where you can find all the stuff from today. That's where you'll find the slides. That's where you'll find all the code for the Hacker News demo we went over, all the code for the safe fire and forget, async command. There's also a bunch of blog posts on there. So if you want to read more about value task, you want to read more about the thread pool, you want to read more about just async and await in general, all listed there, all just for you. Thank you.